Hi guys, how are you? This is today's objective, which is solving trig equations. Today is Monday, March 23rd. The first example, I'm sorry, I think the second example did not upload on the blog at the beginning. So when I checked it again, I made sure I uploaded again. So this is the first example, cosine cube of x divided by sine equals cotan. And again, our objective is to solve. And by solving, if you guys remember, it means find the solution. And find the solution, in this case of trig equation, the solution is x, and x is an angle. So as you notice, the solutions are either degree or radian, but as we agreed by convention, we write our solution in radian unless we are asked to find the solution in degree. So as you see, the first step, I rewrote the cotan to cosine over sine. Then sine on each side of the equation, I was able to cancel both of these out. But there's something very important, and we did that before, not with trig equations, with rational, but this comes back here because we have a denominator. Whenever we have a denominator, it cannot equal to 0. That's what we call restrictions. And when does a sine x equal to 0? On angle 0 and pi. And I actually have here the unit circle. So you guys can see for angle 0 degree, the sine, which is the y value, is 0. On an angle pi, the sine, which is the y value, is 0 as well. So those two values, which are 0 degree and pi, or 180 degree, are not allowed. So when I solve, I am not allowed to get those two values, but I am allowed to get everything else. That's why under restrictions, I put x cannot equal 0 degree or radian, and x cannot equal to pi. Those we call them excluded values. So after we list the not allowed values or restrictions or excluded values, we can keep going. And the golden rule is going to be to equal to 0 factor and solve, or factor then equal to 0 solve. It depends on how the equation is, but usually, as you guys see right here, we subtracted cosine x after we got rid of the denominators. We equaled the equation to 0. Now we have to factor and solve. Factor means finding a common factor, and as you guys can see, cosine cubed minus cosine. And I'm gonna do right here, just like we did last time, a quick reminder using t cubed minus t equals, the common factor is t. T repeats. What stays in the parentheses? How can I make a t cube? It's t multiplied by t squared. And how can I make a t? It's t multiplied by 1. If you guys distribute it again, this is t cubed minus t. Similarly, when you have like a trig equation, cosine cube minus cosine, the common factor is cosine. And what's left inside is as if cosine is the t. So it's cosine squared minus 1. And the cosine squared of x, of course. Every trig function has an input. This is where I came up with cosine x, which is the greatest common factor, parentheses cosine squared minus 1. Then I equal each factor to 0. So cosine x equals 0, and cosine squared minus 1 equals 0. Cosine x equals 0. If you check the unit circle, and I put that as a note, let's go back to our unit circle. Where does cosine equal 0? So we look right here. The cosine is the x value, the x coordinate. So it equals 0 on pi over 2. And it does equal 0 on 3 pi over 2. And always we want to check and say, are those restricted values? No, they're not. So they are both acceptable. Cosine squared minus 1 equal to 0. Now, I think I did like an additional step just so you can see that it's identity 10. But what you could do is, let me show you right here. I don't know if you guys will find this is easier. You can add a 1 on each side. So cosine squared equals 1. That means cosine equal plus or minus 1. So cosine x equals 1 and cosine x equals negative 1. This is just another way to reason about it if you find using the identity is a little hard. And again, cosine is the x value. So where does the cosine equal 0? If we go back right here, cosine is the x value. Where does it equal 1? It equals 1 on 0. And it equals negative 1 on pi. And what do you notice about those two values? If we go back, those two values are excluded values. So that's why we kind of cross this. If you have used the identity, you can cross it right away because a sign cannot equal 0, that the denominator cannot equal 0. If you followed and like more this method, this is going to give you x equals 0. This is going to give you x equal pi. And in both cases, I have to cross these out. Why? Because those are restrictions. So the only solutions will be the ones highlighted, pi over 2 and 3 pi over 2. So I had just quick side notes right here. I think, yeah. When we solve, we want to find the solution. We talked about that. The solutions are the x values, which in this case are angles. So we have to use the unit circle. That's what we did in this example. Whenever we have fractions, there's going to be restrictions. The denominator can't be 0, and that's exactly what we did here. So hope this helps with example 1. Another video will be created for example 2. Thank you.